Good morning, kids. This is your last day of IE, so let's make it a great one. Today we are covering the periodic table, fun stuff. So we are going to go ahead and make our dump page for the periodic table first in this little activity. So I would like you guys to jot down as much as you can possibly remember, as many trends as you can possibly remember about the periodic table. So I'll start you off with one in case you're wondering, what does she want me to put down? So, for example, I would put that groups run vertically. I would go on to go ahead and tell myself what groups, what kind of information I can figure out with groups. And then I can go ahead and jot down that another item that I should possibly know is that periods run horizontally. And again, you should be thinking about what periods can tell you. So I'm going to ask your teacher to pause this information, pause this video while you guys go ahead and jot down any information you possibly can, please. And I'll go ahead and, after your teacher pauses for about 10 minutes so that you guys can go ahead and jot down anything you can possibly remember. Remember about valence electrons, orbitals, reactive, non-reactive, all that business. Please remember that as you are filling in your chart. So teachers, please give them about 10 minutes to go ahead and do this, and then you can go ahead and play the video back on. Thank you so much. I appreciate it. All right, so now you've had a little bit of time to go ahead and fill in your dump chart. So some of the items that you may have put down would have been that groups tell you the number of valence electrons. And I hope that you guys remember that valence electrons are what, kiddos? Yep, number of electrons in the outside shell. Outside shell of an atom. If you didn't write this down, now would be a really good time to do so. So number of electrons in the outside shell of an atom, that's going to be, or outside orbital of an atom, that's going to be your valence electrons. Another trend that I had asked you guys to write down earlier was periods. And periods tell you the number of orbitals. Number of orbitals or electron shells. So I remember asking my kiddos to go ahead and actually draw them out for me, so that way you have a nice little visual. So for example, if you're in period 1 going horizontally, then you have 1 orbital. If you're in period 2, then you have 2 orbitals. If you're in period 3, then you have 3 orbitals, so on and so forth. I'm not going to have you draw them all. We'll go to number 4. 1, 2, 3, and 4. Alrighty, so that was going to be periods and groups. And as we stated before, groups tell you the number of valence electrons. So any element in group 1 is going to have 1 valence electron. Any element in group 2 will have 2 valence electrons. We skip this section, we go on over here. 3 valence electrons, 4, 5, so on and so forth. Another item that you should probably have written down was going to be the reactivity of these atoms. So please try your best to remember which ones are reactive versus non-reactive. So hopefully in your chart, in that time that your teacher had paused the video, you wrote down that anybody in group 1 was very reactive. In fact, the number 1 most reactive group. And that's going to be because it only has 1 valence electron. Remember, they need how many to be happy? Hopefully you said 8. So they needed 8 to be happy. So this guy only has 1. So he's really wanting to go ahead and just give up his 1 to somebody who only maybe needs 1. So that way he can be nice and happy. The second most reactive was going to be group number. Do we remember? Yep. Group number 7. So 7 is going to be the second most reactive. And again, that was going to be because they already have 7. They only needed 8 to be happy, so they're super excited. They just need 1 more to go ahead and be happy, so that's why they are the second most reactive. And lastly, we have Group number 2. Group number 2 is going to be the third most reactive. Okay. The only other trend that we talked about with the periodic table is group number 8, or characteristic I should say. Group number 8 over here. This guy already has 8 valence electrons, so he is already super duper happy. He's full, he's like, don't give me any more, I can't accept more anyway. So this guy right in here is going to be very stable and not reactive. Okay. Since I'm talking about the periodic table, some items that I might also be able to go ahead and jot down are some of the trends having to do with ape man. So I'm going to go ahead and write down ape man right up here. A equals P equals E. We talked about this in our first IE, where A is the atomic number, P is the number of protons, and E is the electron number. They all equal each other. So if you know one, you know them all. The man part comes for finding out the number of neutrons. So this is something else I'd be writing down on your paper if you haven't done so already, where the M stands for the atomic mass. The A, we already said, was the atomic number. And the N, once you subtract these two, the mass minus the atomic number, you get the number of neutrons. One of the last things that I'll put on here is one of the teaks that we covered, how the proton number identifies an atom. So that makes sense now we look at ape man, because if we have the atomic number, then we have the proton number. So vice versa, if we have the proton number, I know my atomic number. And with that atomic number, I can definitely identify an atom on this periodic table. All right, so now we are off to answer some questions. So I'm going to go ahead and turn my paper over. And in fact, if you want to go ahead and remove this, you sure can, so that you can have it to kind of look back and forth on. In fact, I'm going to go ahead and do that now. Okay, so I'm going to ask that your teacher please go ahead and pause this video so that you guys can go ahead and have about 20 minutes to go ahead and take, if you need 20 minutes, maybe 15, 20 minutes to go ahead and answer these questions by yourselves, please. And then I'm going to ask them to go ahead and press play again, and I'll go ahead and go through these with you to make sure that we all have the right answers and try to figure out how we got them. All right, thank you so much, kiddos. Good luck. Try real hard, okay? Like I said, this is your last IE. Our test is next week, and you're going to rock it out. I know you are. But let's go ahead and try our best, and let's do process elimination, underline whatever you can in order to help you get the right answer. Thank you, kiddos. Good luck. About 20 minutes, 15, 20 minutes. All right. So by now your teacher gave you about 15 to 20 minutes to go ahead and answer these questions. So I hope that you guys have had ample time and you used your skills to go ahead and get the best answers. Let's go over them. Question number 1 says tin, or SN, is a soft white metal. It has a low melting point compared with other metals. Tin is widely used as a coating for cans of food. Which statement accurately defines tin? Well, they gave me the chemical symbol, SN. So my first job was probably to go ahead and find it over here. And it said SN, so I find that SN is right here, tin. What I also see is that it has the atomic number. And as we stated before, the atomic number is equal to the proton number, right? Atomic number equals proton number. So because of that, I come back over here and I see SN is equal to 50. So right in here we have, the answer should have been right here, letter F. 10 atoms have 50 protons. And again, that's because they have an atomic number of 50. Moving on to number 2. Number 2. The atoms of a certain element each contain 11 protons and 1 valence electron. Which statement correctly identifies this element and describes its chemical reactivity? Okay, so now we're talking about reactivity. It says that it contains 11 protons. That should really have been a key, right? So right in here, here's the TEK. It says to identify the protons, identify that protons determine an element's identity and valence electrons determine its chemical properties, including reactivity. So if I know the proton number, I also know its atomic number. So you should have gone to your periodic table and gone over here to where it says atomic number of 11, and here I have sodium. So I should know that it's going to be sodium. I come back over here. Okay, sodium, okay, it could be it, highly reactive. Fluorine, nope, not it. Sodium, nope, not it. Excuse me. It could have been sodium. Not very reactive though, so I'm not sure. Fluorine, nope, not it for sure. It's got to be sodium. So now let's take a look at what group it's in. So I come over here, here's sodium, and it's in group number 1. So lo and behold, we had already put on here that it was going to be the most reactive group. So I come back over here. The element is sodium and it's highly reactive, or the element is sodium and it's not very reactive. So this is going to be the answer right here. The element is sodium and it is highly reactive. Hopefully you guys got that. All right, moving on to question number 3. Question number 3. Hey. Question number 3. Students were asked to identify the location of elements in the periodic table. Sorry, let me move it over here. Students were asked to identify the location of the elements in the periodic table based on clues printed on card games, okay, and game cards. So element number 1, it was shiny black. It's a metalloid. Okay, well, metalloids, I know it's got to be somewhere in here. It's got 3 valence electrons. Sorry, that's kind of hard to read. It's got 3 valence electrons, which means it's got to be in group 3. So group 1, 2, and 3. So this should have been element 1. Oh, excuse me, and it has 2 energy levels, so it should have been in here. So this should have been number 1. So that's not it, because that says 3. I take a look over here. Again, not it. So my answer choices are down to this one, to G, and J. So as I do that now, I take a look. Okay, I'm going to have to go to another card to go ahead and help me finish determining this. So I come over here and I take a look at element number 2. Element number 2 has 5 valence electrons, which means that it needs to be in group 5. So here's group 1, 2, 3, 4, 5. Okay, so it's probably going to be this one, but let's make sure. 1, 2, 3, 4, 5. Oh, nope, nope, that's not it. This is not the correct element. So yes, G was the best answer here. All right, we're going to move on to question number 4. Please make sure that you're following along and you're doing everything that you possibly can. All right, question number 4. Which pair of properties describes the elements in group 18? Which pair of properties describes the elements in group 18? Okay, so let me take a look at group 18 over here. Okay, as I'd already written down, group 18, it says it's not reactive. It's really stable. That I didn't necessarily write them down here, but we also know that these guys are noble gases. This might have been something I should have written down in the first place. These are noble gases. Okay, so now let me go ahead and see if I can answer these questions based upon that. Elements in group 18. They are chemically stable. Check. And are liquid at room temperature. Probably, but let's hang on. Let's see. Let's see. They have 8 valence electrons. That's true. And are flammable. They are magnetic and boil at low temperatures. No. They are gaseous. Gas, right? Noble gases. And chemically stable. Check, check. So yes, I was able to find the best answer here. And again, this one was not correct because this one right in here says it's liquid at room temperature. We just finished saying that these guys were noble gases. Very good. All right, so letter J was the best answer there. Number 5. Element R and element Q have the same number of valence electrons. These elements both have similar chemical behavior, but element R has fewer energy levels than element Q. So here's element R, here's element Q. Which statement best describes the positions of the two elements on the periodic table? So one of the things we should have realized is that these guys both have 2 valence electrons. So they would both be in group 2. But we can see just by looking at it that they would be in different periods. Why? Because this one has 1, 2, 3 energy levels, or 3 orbitals. And then this one has 1, 2, 3, 4 orbitals or energy levels. Okay. Another piece of information that they give you is the number of protons. This says 12 protons. So I come over here. Oh, look. Who has an atomic number of 12 is going to be magnesium. So I can even put an Mg here. And then who has an atomic number of 20? Oh, look, calcium. So that makes sense, right? Magnesium has 3 orbitals. It's in period 3. Calcium had the 4 orbitals, so it was in period 4. So now let's go ahead and take a look at which one best describes it. The answer here should have been letter H. The 2 elements are in the same group. True story, right? They're in the same group, magnesium and calcium, with element R just above element Q, with Mg being just above Ca. Yep, Mg is just above Ca. So good job, letter H if you got that. All right, question number 6. Students in a science class prepared flashcards so that they could quiz one another about the arrangement of the periodic table. One of the flashcards contained information about two elements, element L and element M. Okay, the students had to use the information on the flashcards to determine possible positions of the 2 elements on the blank periodic table. Which periodic table has the elements placed in the locations that match that flashcard? It's a bit hard to read on mine, but it says both elements are metals. Okay, so that could have been something else that I put on my deal that I did not earlier. So over here, we're going to have metals to the left, non-metals to the right. Remember, M comes before N if you're having issues with where is that. So just think about it alphabetically. M comes before N. And then over here at the little staircase, those guys were going to be my metalloids. All right. So this says both elements are metals. Okay, got it. So I know that they have to be in this left-hand section somewhere. It also says that both elements are, let me read this, more reactive. Oh, excuse me. That atoms of element L are more reactive than atoms of element M. Yep, that says M. So, sorry, that was really hard to read. So right over here, we're going to say, okay, well, I know that L has got to be more reactive than M. And again, thinking about my groups, which ones are reactive versus the other ones that are not. So L is more reactive, so I know that I can't have them both in the same if one's more reactive than the other. When we're talking about reactivity, again, if it said that L was more reactive than M, over here in letter J, M is more reactive than L. Remember, this is the first most reactive group. This is the third most reactive group, so that's not it. H has M over here in this section. This is going to be somewhat reactive, but L over here, same thing, somewhat reactive, but not a whole lot, so therefore that's not it at all. So letter F was going to be the best answer here because L is in the most reactive group versus M that is going to be in the somewhat reactive group. Okay. Also, you could have gone ahead and over here, again, I know it's hard to read, but it says atoms of element M have 2 more valence electrons than atoms of element L. So 2 more valence electrons. So this one has 1 valence electron because it's in group 1. This has 2, this has 3. So yes, element M did have 2 more valence electrons than element L. There could have been many ways in which you could have gotten this correct. So yes, absolutely, this is the best answer here. Question number 7. The periodic table is organized into groups and periods of elements. The characteristics of a certain group of elements are listed below. Okay, it's shiny, solid at room temperature, has atoms with 2 valence electrons. This right in here was super duper key. If it has 2 valence electrons, I know that it should have been in group 2. So I'm going to bring out my periodic table, I'm looking for somebody in group 2. Lithium is Li. Nope, that's group 1. Strontium, I believe, is St, but I could be wrong. Strontium, let me find it here. Oh no, here's strontium. Strontium is Sr, and it is in group 2, so that might be it. Okay. Aluminum, Al. Let's see, where's aluminum? Oh, aluminum's over here. That's in group 3. Nope, not it. Silicon, it should be Si. Si. Here's silicon. Nope, group 4. So not it. So yes, the only one in group 2 would have been strontium. So 7 was letter G. Number 8. Which 2 elements on the periodic table are in the same period? All right. So I'm looking for somebody who is going to be in the same horizontal rows. This is what I'm looking for. So I go ahead and I just have to start doing process elimination. I have Sn and Rb. Oh, look, here's Sn and Rb. Oh, look at that. They are both in period 5. This is probably it, but let's just make sure. F and Cl. Okay, here's F, here's Cl. Oh no, they're in the same group, but they're not in the same period, so not it. K and Ba. Here's K. Where's Ba? Or Ba. K and Ba. Nope, not in the same group or period. Nope. Se and Te. Se and Te. So they're in the same group, but not the same period. And my question is asking me about the same period. So yes, letter A was the right one. Last questions, kiddos. I know you guys are tired. You've been doing a good job, though. Last question. A student is studying the different elements. Excuse me. A student studying the... Shoot, I can't read this. A student is studying the ways different elements are similar to one another. Diagrams of atoms from 4 elements are shown below. Okay, great, good. Which 2 atoms of the elements are in the same group in the periodic table? Okay, so I'm looking for items in the same group. That's what I'm looking for. So again, I would have highlighted or underlined the word same group. So group is equal to valence electrons. Okay, so all I've got to do now is go around and count how many valence electrons they have and see which ones have the same ones. So 1, 2, 3, 4, 5, 6. This one has 6 valence electrons. Remember, valence electrons are the ones on the outermost shell. 1, 2, 3, just 3. 1, 2, 3, 4, 5, 6, 7. This one has 7. 1, 2, 3, 4, 5, 6, 6. Okay, so it should be atom 1 and atom 4. Is there an atom 1 and atom 4? Yes, there is. The answer was letter G. All right, kiddos, you have finished this up. Thank you so very much for your time. You've done a great job. I know you guys are going to rock it out. Ms. Van and I are very proud of you. And thank you so much to all the IE teachers for doing your best and making this happen for us. Have a great Tuesday. Bye, guys.